Let's take a look at the system architecture of our smart dustbin. In the middle, we see an Arduino, which is used as the controller for our entire project. Now, this Arduino is connected to several modules. First, we notice the red LED and green LED present at the top. These are connected via analog pins of the Arduino, and they denote whether the dustbin can or cannot be opened. We also have two ultrasonic sensors. One is placed inside the lid of the dustbin to detect the level of the waste. Now this level decides whether or not the dustbin can be opened. The other ultrasonic sensor detects the presence of a person in order to open the dustbin. So if the person is close enough distance wise, the dustbin will open as long as the level of the dustbin is not full. The lid is opened by the servo motor, which is connected simply with 3 pins to the voltage supply, ground, and the PWM pin. Now this is used to lift the lid up. The ultrasonic sensors have trigger pins and echo pins that need to be connected to the Arduino. Further, there is a thin film display, transistor display, which is connected with 9 pins. Now these 9 pins are denoted as follows. And the key ones are the clock, the master output slave input, the master input slave output, the chip select, the voltage supply, and the ground. As long as these are connected, the thin film display will work. We also have a LoRa module, which is used to communicate with another LoRa module, which is connected to a PC. Now the data is transmitted from the Arduino to the LoRa module and fro via these two pins, RX and TX, which are connected to pin number 4 and 5 of the LoRa module. So we took this system architecture and we tried to implement it on another software called Tinkercad, a simulation software. Now this simulation software looks like this, and these are the connections we have made. Here we see an object detection sensor, which is whether the person is close enough to the dustbin or not to open it. And this ultrasonic sensor detects the level of waste. This is the servo motor present as denoted, and it needs its own power supply as well as an oscilloscope to notice whether there is a pulse that is sent towards it. This is the Arduino is controlling all of the processes. As you can see, there are two modules missing from this simulation software. The TFT display and the LoRa module, unfortunately, are not on software and thus cannot be simulated as we desire. Although this is the case, we will make sure to write the code that works for the modules and so that a project can be realized fully. Now we will move on to the simulation and the discussion of code.
Hi, I am Dion. Now that Lloyd explained the outline of our product, I will run the simulation to demonstrate the working of our product on Tinkercad and explain the code. For the purpose of demonstration, since we do not have a TFT display, we shall use this serial monitor for all display purposes and the LED lights here to indicate the status of the dustbin. So as you can see, there are two ultrasonic sensors, and the states of both these sensors decide whether the lid of the dustbin should open, close, or remain closed. So we have limited the range of the object detection sensor to be 1 meter and the range of the level sensing sensor, which is inside the dustbin, to be 30 centimeters. We have changed the position of the sensor to sense the height of the dustbin instead of the diameter as previously done. So this will give us a percentage of how full our dustbin is. So in the first case, the dustbin is not at full capacity, which is indicated by this marker here, which is within the range. Now when a person comes within 1 meter distance, we see the servo motor turn by 90 degrees to lift the lid, and this is indicated on the monitor as well, indicating the status that the dustbin is full, and it says it's 14% full, which is determined by this marker here. Additionally, you can see the green light, which means the dustbin is still in use, which was also the case initially. So even when you move out and the dustbin closes, you see the percentage has slightly increased to 17% full, which is when the person has dumped something inside, but the status still remains green, which indicates that the dustbin is still in use. Now secondly, when you move the marker less than 3 centimeters, this indicates that the dustbin is filled and then there's no more capacity. So when you have it at this position, irrespective of when a person comes close or not, the dustbin is not going to open. Now if we move this marker such that it is not full, you see when a person is near, it opens. But even if a person is near and the dustbin gets full, it says it's 100% full and close. So irrespective of whether the person goes far or near, the dustbin remains closed. And as you can see, there's a change in the indication of the LED, which turns to red, so people can also identify which dustbins are used by the LED that's on the dustbin. So that's with regard to the working. Now coming to our code essentially consists of 5 functions, which include the setup and loop functions. We have 2 functions controlling each of the ultrasonic sensors, which activate the trigger and detect the echo in order to calculate the distance. The main difference in these 2 functions is the range of sensors. So the object detection sensor being 1 meter and the capacity sensor being at 30 centimeters. We then have the display function, which controls the serial monitor and displays appropriate messages on the screen depending on the state of the sensors and the status of the bin lid. Now the reason we need a different function is because if we put it in the loop function, it will print repeatedly, but we need it to print only when there's a change in state. And finally, we have the loop function, which essentially runs the entire program by continuously making the appropriate decisions. And with that, I conclude the Tinkercad demonstration.
This is our setup that we could manage to do during this pandemic situation. We were able to get hold of an Arduino Leonardo, a servo motor, 2 ultrasonic sensors, and a Bluetooth low energy device instead of a LoRa module because it wasn't available at the EE lab. But yeah, we hope that this gives a good idea of how our project works. We weren't also unfortunately able to get a dustbin with a lid to make use of the servo motor, but we can still show how the servo motor works. We're using an online, we're using the Arduino IDE, which is with our code so that we can compile it and upload it to the Arduino. Yeah, so the first step is to verify the code and make sure that there are no errors. And once it's done compiling, we then we would then need to connect the Arduino to the we then need to connect the dustbin to the Bluetooth device to the mobile application. Once the connection is established, we then upload our code to the Arduino. once we upload our code, we get the notification initially that the dustbin is closed. And then the ultrasonic sensor being used for the dustbin is this one. So once we put our hand above it, we get the notification that the dustbin is open. This goes on for about 10 seconds before it closes again, and we can see the servo motor rotate. I know it's a little hard to see, but yeah, though it makes a small noise which shows that the motor is rotating. Yeah, so then again, put your hand above it, the dustbin will open. Take your hand, close it, and then the dustbin gets a notification that the dustbin is closing. The application gets a notification that the dustbin is closing. So yeah, this is our demonstration of the live version.